Hello, this is Mr. Huber. In this lesson, we're going to learn about solving systems of linear inequalities. Now, if you recall, we've graphed single inequalities in two variables before. That's where we want to get a boundary line by getting the y by itself and graphing it as if it's a y equals mx plus b, except we determine if it's a dashed line when we have just the less than or greater than, and a solid line if we have the equal to with our less than or greater than sign. So we graph the boundary line, and then we have to test a point. That's where we can pick a point, typically 0, 0 if possible, because it's easy to plug in, and see if that point works so we know what side of the line we should be shading. Then after we test the point, determine, we'll shade either the side with the point if it is a solution, or the side that doesn't contain that point if it's not a solution. So we're going to graph the boundary line, test a point, and then shade one side of the line or the other. Now, when we solve a system of inequalities, we're going to have two inequalities graphed and shaded on the same coordinate plane. And our solution is going to be where both those shadings overlap. So we're going to have two sections of graph shaded. There's going to be a portion of it where they overlap, and those will be the solutions for both inequalities, right? The shading for one, the shading for the other, we want to know where they're both shaded. That's the solution for the entire system. Those would be the points that solve both inequalities in the system. All right, let's see what that might look like here by determining if a point is a solution for this system. So we see that we've got two inequalities graphed here. One's a dashed line, one's a solid line. And for this dashed line, right, we're shading this side of the line. So really, the shading for that first graph would be all of this, right? All of this here, right? That would all be shaded for that dashed line. And then for the solid line, we're shading one side of that line. That would really look like all of this portion here that's shaded. And we see where is the blue and the red overlapping? It's in this area in here, right? That's that portion that was shaded where the two overlap. So our solutions would be points in that shaded area. Okay, so now let's look at what that looks like when we test a point to see if it's part of that solution set. So keep in mind, right, we're solving to see where the solution is for the entire system. Okay, so now we're going to take and we're going to want to check a point. Let's take the point 0, 4. All right, so the point 0, 4, if we look at where that point would be located, all right, let's do that here in green. 0, 4 would be the point right here. 0, 4 would not be a solution for that system. It would be a solution for that solid line. It's on the side of the solid line that would be shaded, but it's not a solution for the entire system. So no, that's not a solution. 4, 2. So 4, 2, we'll put that point in blue. So we go 4 to the right and then 2 up. Make sure we're doing x, y. So 4, 2 is yes, it's a solution for that system because it's part of where both of those graphs would have been shaded. And let's check 2, 4. So 2, 4 is a point right there. It's right on that dashed line. So the dashed line means less than, not less than or equal to. So not equal to the line, but it has to be less than the line. So no, that would not be. If it's on the solid line, then yes. So for instance, if I had this other blue point right here, let's say 2, 1. 2, 1. Yes. Because it's on the solid line. So the solid line is included. Right? The dashed line is not, like our open circle and closed out on a number line. Keep in mind, that's telling us when we're equal to the line or not equal to and just on one side or the other. So now we're going to get to where we actually graph some. But we want to keep in mind what that means to shade and find where the shadings overlap. That gives us the solutions for that entire system. All right. In this problem, we're going to graph this system of inequalities. So we're going to start here with this first one. Y is less than or equal to 2x minus 1. It's already got the y by itself, so that's good. We can graph it like we see it. So we're going to go to -1 on our y-axis. That's our y-intercept. Then we're going to go up 2 over 1. And we could put a few more points. We can keep going up 2 over 1. We go down 2 and left 1. We get us some points. And our line is going to be right here along those points. Okay? And it's got the equal to. So we're going to have a solid line. So we're going to have a solid line that goes through those points. Now we have to figure out what side to shade. So if we test the point, and if you're looking at this and going, I don't know if 0, 0, it doesn't go through 0, 0 because you see it goes through 0, -1. But if you're not sure, then that's fine. Then you could test the point 0, 2 or 1, 4, something you know. You could do 3, 1, something you know is not on the line. I'm going to use 0, 0. But if you're not sure, just make sure it's something not on the line. If 0 is less than or equal to 2 times 0 is 0 minus 1. That 0 is less than or equal to -1. 0 is not less than or equal to negative 1. So that means, remember, we're not going to shade this side. We're going to shade the other side of the line. So I'm going to shade that here, all this blue. Okay, that's going to be my shading there for that inequality. And now I have to graph the other inequality. So in green, we're going to have y is greater than negative 1/3 x plus 4. Already y by itself, so that's good. I can go to my y-intercept of 4. I'll go down 1 and over 3. Down 1 and over 3. And I can go up 1 and left 3. It's fine. And now when I graph this line, it's going to be a dashed line because I have the greater than, not greater than or equal to. So keep that in mind. I want a dashed line now that goes through those points. Okay, there's my dashed line going through those points. And now I want to shade. So I can test the point. I could test 0, 0. So I'm going to have 0 is greater than negative 1/3 x times 0 is 0 plus 4. So I have 0 is greater than 4. 0 is not greater than 4, so I'm going to shade the other side of the line, so that's going to be all of this here. Okay, and so we want, where are the shadings overlapping? So we have blue shading here, green here. If I pick a point over here, it's going to work in this inequality, but not in this one. If I pick a point over here, it'll work in this inequality, but not this one. This section of the graph is the only points that will solve both inequalities. So that is my shading then that I'm going to include. This here, I'll do it on red here. This shading is my solution area. Okay? And it would keep going. It would keep going up this way forever, out this way forever. Okay? And that section of the graph would be all the solutions for that system of inequalities. And we could check a point too if you want. Pick a point in that red shading and check and see if it works in both inequalities. This system of inequalities has 3 graphs. Okay, so let's see what that looks like. So let's graph the first one. It's already got the y by itself, so we can start with y is greater than negative x plus 2. So I go to my y-intercept of 2, then down 1 over 1. That negative 1, right, negative x means like negative 1. And I could go up 1 and left 1 as well. And I'm going to have a dashed line. So I have a dashed line here because I'm not including the line. So there's my boundary line, and now I have to figure out where to shade. So to figure out where to shade that, again, I'm going to test a point. We'll test the point 0, 0, because again, that's relatively easy to check. 0 is greater than 0 plus 2. 0 is greater than 2. 0 is not greater than 2. So I'm going to shade this side of the line here. All right, so that's my shading for that. Now I'm going to take the next one, 3y is greater than or equal to 5x minus 12. Right, so I'm going to have to divide by 3 everything to get the y by itself. So I'm going to have y is greater than or equal to 5 over 3x minus 4. So my y-intercept is negative 4. I'm going to go up 5 and over 3. Okay, so from this point, I'm going up 5 over 3 because it's a positive 5 over 3. And I could keep doing that. I could go up 5 more and then over 3 more. And I could have a point there. And I could go down 5 and over 3. And I'm going to have a solid line through these points. So I'm going to have a solid line through those points. And that's my boundary that I'm going to test a point 0, 0. Test it back in the original inequality. So 3 times 0 is 0, greater than or equal to 0 minus 12. So if 0 is greater than or equal to negative 12. That's true. So that means I'm going to shade the side that has 0, 0 on it. So 0, 0 worked, so I want to shade that side of the red line. So I'm going to do that here. I can shade everything on that side of my red line. Okay, and I have one more to graph. Y is less than 5. So this is one of those special cases. A y equals is just a horizontal line at y equals 5. So for this, I'm going to take a dashed line across y equals 5. There's my graph for that. And then less than 5, I want numbers less than 5, so below it. So I'm going to have everything in here. And I want to see where the green, red, and blue all overlap, and that can be a little challenging sometimes. So you want to make sure here we've got our section right in here of this graph, kind of a little wedge there. Okay, so that's my section of the graph. It's all the points on this side of the green dashed line, this side of the red solid line, and below this side of the blue dashed line. So it can be helpful to shade lightly if you want, shade horizontal lines and vertical lines, something that helps you kind of identify where they're overlapping, and test a point at the end. I could pick a point in here and test it and make sure it works in all 3 of those inequalities. Okay, so graph the boundary line, figure out which side to shade. Now we need to see where all of our shadings overlap. And that's our solution for that whole system of inequalities. All right, before we see some more inequalities, a little pause from Pause. Tiger's mascot Pause there, he looks like he's thinking about something. Maybe wondering, this striped fur, where does this striped fur come from? It goes a little deeper than the fur you see. You see, tigers have striped skin, not just striped fur. So that skin underneath that's striped gives the fur the stripes that we see. All right. Let's see another system of inequalities. We're going to write a system of inequalities that goes with this graph. So first I'm going to take the vertical line. Okay, the vertical line here, we're going to have to write an inequality for both these. So I'm going to start with the vertical line. So I've got my vertical line here, okay? That is at x equals 1, 2, 3. So x equals 3, right? It's a solid line, and I want numbers that are less than 3. So I'll trace over that in green here so we make sure we know this is a green one I'm going to write. So that's going to be x is less than or equal to 3. X is less than or equal to 3. And then I've got my dashed line, okay? So my dashed line, we'll do that in blue. To write the equation of this line, I want to get a y equals mx plus b. So I need a b. I got my y-intercept right there. My b is -1. My slope, okay, I want to count, say from this point to this point. I want 2 points I know are on the line. I go up 1, 2, over 1, 2, 3. I go up 1, 2, over 1, 2, 3. I keep getting points on the line. So that's my slope, 2 over 3. So my slope is 2/3. And now I can write the equation for that line. I'm going to have y, and I have 2/3 x minus 1. Now, is it a less than or greater than? That can be a little trickier. The x equals, we could see here, x, I want numbers less than x, right? That's 3, I shaded in 2, 1, and so on, numbers less than x. Okay, so it's left or right or up or down might be easier. Here I think, okay, my shading is kind of above this line, so I think greater than. And then I could check it and see. So I'm going to write this as a greater than, not equal to, because it is a dashed line. And let's test the point 1, 1, or 0, 0, excuse me. So we're going to test the point 0, 0 and make sure that works in the inequality I wrote. So I'm going to have 0 is greater, 2/3 times 0 is 0 minus 1. So I have 0 is greater than -1. That's true. So it looks like my inequality here works, because when I plug 0, 0 in, it was a true solution. If it wasn't, if I had 0 as less than -1, I could go up here and go, oh, I need to switch that. I didn't want a less than, I want a greater than. Pay attention whether that is the equal to or not, solid line equal to, dashed line, just the inequality. And so this would be the system of inequalities that would give me that solution set, that shaded region. So remember, graphing an inequality in two variables. You need to graph a y equals mx plus b boundary line, or if it's a vertical or horizontal line, know those special cases, x equals for vertical, y equals for the horizontals, and then we have to figure out where to shade. After we shade, when it's a system, where do the shadings overlap? And we can always test a point. Anything in that shaded region should be a solution for the entire system.